Water hardness. This is the topic. Different type of water you can find. Some are called hard water and some are soft water. Soft water means it contains little amount of salt, TDS, total dissolved solid. This is they are in the very small quantity. And hard water means it contains salt in a large quantity. And particularly calcium magnesium ion responsible for hardness. Iron also, aluminium iron also maybe, but calcium and magnesium is considered as the major one for the hardness. Now there are two types of hardness. Hardness again we can classify into two categories. One is called temporary hardness and permanent hardness. Temporary hardness means we can remove the hardness by boiling, adding lime water, etc. And permanent hardness means we cannot remove that hardness by that type of simple treatment. Not possible. Why? Because temporary hardness is caused by bicarbonate ion and carbonate ion. And carbonate usually insoluble. Like calcium carbonate is insoluble, magnesium carbonate is insoluble. And already I told you that calcium and magnesium is the major reason for the hardness. Why? Why so? Sodium potassium salts, they are not reacting with soap. And definition of hardness is that water that cannot produce sufficient lather or foam with soap is called hard water. Okay? Any water that cannot produce sufficient lather or foam with soap is called hard water. Now what is soap? We must understand that first. What is soap? Sabanta ki. That is a mixture of salts. Sodium potassium salts of stearic, palmitic and the oleic acid. This type of acids are called fatty acid, higher fatty acid. Okay, means long chain fatty acid. What is fatty acid? It is actually produced from fat. That's why it is called fatty acid. These things are produced from fat. Okay, by hydrolysis of fat, we are getting this type of compound, and the process is called saponification. Okay, this hydrolysis technique is called saponification. By hydrolysis of animal fat or maybe plant fat, any type of plant origin, or like dalda, vanaspati. So these things are plant origin, plant or tree, and some fats are available from animals, animal fat. So this type of oils and fats are hydrolyzed with the help of sodium hydroxide, caustic soda, or potassium hydroxide, caustic potash. By using caustic soda, caustic potash, this hydrolysis is done, and by this hydrolysis, this technique is called saponification method, and by that we are getting the sodium potassium salts of stearic, palmitic and the oleic acid, and we compress, remove the water, extra water, and we get some bar soap cake that is produced this way. And what is the stearic acid, palmitic acid, oleic acid? They are long chain higher fatty acid. For example, C17H33COOH. Okay, C17H33COOH. That is stearic acid. Palmitic acid, as there is a 15. Instead of 17, carbon number is 15. C15 and H 2n plus 1. So 15 and 2n plus 1 means 31 COOH. So you can remember, it's not difficult. Now C17H31 COOH, that means one double bond present. That is called oleic acid. So stearic acid, palmitic acid, oleic acid, these are called higher fatty acid. Sodium potassium salts of these compounds are called soap. That soap we are using for taking bath, for usually taking bath. Others are detergents like that. Like what is detergent? Detergent is sulfonic acid. Soap is carbonic acid, salt. Carbonic acid salt, and detergent is sulfonic acid salt. Got it? That is the basic difference. One is sulfonates, salts of sulfonate, and other one is carbonic C double H compound. That means oic acid. We call it oic acid. Organic acids are called oic acids. Sodium potassium salts of this higher fatty acid. Got the idea? Minimum idea what is soap and all. Now this type of soap reacts with hard water, producing calcium magnesium salts of stearic palmitic oleic acid. Earlier it was sodium potassium salts. Now in the hard water, as there is calcium magnesium ion present, that will react with that soap, producing calcium stearate, magnesium palmitate, calcium oleate type of compound. These are insoluble, cannot produce lather or foam. That's why soap reacts with hard water, producing scum, SCUM. What is scum? That calcium, magnesium salts of stearic, palmitic and the oleic acid, they are called scum, producing white flock-like material which is insoluble to water and gets precipitated out. And that's why the soap is wasted and you are not getting any cleaning. Got the problem? So if it is hard water, detergent is better compared to soap. But always we cannot use detergent. We cannot wash ourselves with detergent. That is true. So soap is usually comparatively soft, and this is very rough detergent. That's why detergent is not supposed to use into good clothes also. If you take for garments, if you use this soap, instead of soap if you use detergent, there will be bubbling. You know bubbling, na? Small bubble like things comes out from your cloth, garments. That is called bubbling. Tulo phule thake na, phule hoye jay. After a few wash, not immediately, after a few wash you find that there are small cotton thread like bubbles coming out from the surface of the cloth. That is called bubbling. And that happens due to rough type of soap usage. If you take powdered soap and all. If you use liquid soap, that problem will be less, because it is comparatively for delicate clothes. The liquid soap is used for delicate clothes. Silk, you have gentle, you have easy, right? So they are actually soap, all are soap, but very gentle quality. They maintain the pH and all. So if you take ordinary soap, take it a litmus paper, a moist litmus paper, and touch on the ordinary soap, what do you find? No, it will become alkaline. It is alkaline, so it will become blue. Red litmus will become blue. So that is alkaline. But if you take some neutral soap like Dove, they claim Dove.
Color will not change.
No, color will not be changed. So these are some basic minimum ideas regarding soap and detergents. So what is detergent? Sulfonic acid groups. And what is soap? Oic acid, C-double-H. And these are higher fatty acids. And like lauryl sulfate, potassium lauryl sulfate type of compound, these are called detergents. And soap, stearic, palmitic and oleic acid, sodium potassium salts. Another idea, sodium salt comparatively soft soap, and potassium soap make it harder. Hard soap, soft soap. Some soaps are very soft and it become very thick, muddy type of material with water. That is actually sodium salts more. And if binding is good, that is not getting washed away so easily, potassium salt component is more. So sodium soap is comparatively more delicate and soft, and potassium soaps are comparatively harder. Less fancy, there is a soap. It goes on and not getting washed away. So that of thing. Now what is there in front of you? Let's have an idea. If it is surface water like river, lake, then that water is soft water. River and lake water is soft water. But underground water and marine water, hard water. Why? Any idea? Why? How do you classify like that?
Sir, in the underground water, lots of minerals and like ions are dissolved.
Dissolved. So, why it is dissolved? Because whenever the water percolated through the ground, in the ground soil, there are a lot of minerals that is getting dissolved in the rainwater, particularly rainwater. And when the aquifer is filled up with this rainwater, lot of salt is already dissolved, so it is becoming hard water. because it's percolating through the different layers of the strata of the soil and ultimately getting accumulated below the ground. So that's why it is becoming harder. But soft water, this water, river water is comparatively soft because the water is coming so fast from the ground, continuously flowing so fast that upper surface salt content already is reduced and sufficient salt not getting dissolved, and that's why soft water becoming soft only. It is kept as soft only. So that is there. Now this is what? Water treatment plant. So softening treatment plant. Softening. Water softening. Hard water gets softened here. Like resin method. So different some methods are there. This is plant shown. The picture has got meaning. That's what I'm telling you. Now what is this here? So you have a sort of cyclic process. Carbon dioxide is there in the atmosphere. It is going to the atmosphere and it is coming back from the atmosphere to the ground. Soil to atmosphere, there is always a to and fro movement. How? Whenever acidic rainfall occurs, carbonate producing carbon dioxide that is going to the atmosphere. Now sometimes if the soil is alkaline, it is absorbing carbon dioxide from the air and it forming carbonate and bicarbonate. Not only soil, the marine water itself can dissolve lot of carbon dioxide in the form of carbonate and bicarbonate that is getting precipitated at the bottom of the ocean, and that is happening. So ocean is having a very important role into our atmosphere environment. It has a very crucial role. It is absorbing lot of carbon dioxide. If ocean is not absorbing carbon dioxide, the global warming will be enormous. Actually, carbon dioxide is checked by ocean. It is checked by ocean. But if the salinity level of the ocean goes down, then the carbon dioxide dissolution will be less. Salinity level means salt content. If the salinity level of the water, ocean water goes down, then that carbon dioxide will not dissolve much. It will dissolve less. That is called synergic effect. If there is a water coming from the glaciers and mountains and mixing into the ocean water, reducing the salinity, it will dissolve less carbon dioxide. So carbon dioxide level in the atmosphere will increase more. Global warming will be enormous, and it will because of temperature rise, glacier and polar ice caps will melt more. So that effect is called synergic effect. Got the idea or not?
Yes.
So both are actually enhancing each other. That global warming is melting more ice, that is decreasing the salinity level of the ocean, and that's why ocean is absorbing less carbon dioxide, and that's why greenhouse effect is more. So that is type of effect is happening in the nature. So balance is very nice, fantastic. But somehow if the balance is broken, then devastation, really devastated. That happens. Okay. So this is the thing I was telling. Carbon dioxide is getting reacting with acidic water, rainwater, producing carbon dioxide, carbonate to carbon dioxide, that is going to atmosphere. And whenever the rainfall is less, drought situation, it is absorbing more carbon dioxide because soil becomes alkaline. During rainy season, soil becomes more acidic, and in other season when there is no rainfall, soil becomes more alkaline. Okay. So now this water hardness, particularly this language you read out yourself. So I am just telling you regarding the equation. So this is what? Soap. I was telling you soap. So that stearic, palmitic and the oleic acid. So the structure is so long, nothing too difficult. CH3, CH2, 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 go on. Total carbons will be 17. You can do yourself. So CH3, CH2 whole 16, COOH. You can easily remember. Stearic acid is what? CH3, CH2 whole 16, 17 angle, then COOH. That is called stearic acid. So now this R is representing that long chain alkyl group, COONA. So it is reacting and giving precipitate, that is called scum. Giving precipitated out with the hard water, and this is called scum plus N2 so forth. And so what is what is the reaction signifying? This signifying that soap is getting wasted by reacting with hard water. The meaning of this equation, why I have written this equation here, the meaning is whenever you are using soap into hard water, the soap is getting wasted and you are not getting any benefit. Cleaning will not be done. Cleaning will not be done. It is bad for you, bad for clothes, bad for everything. Bad for boiler feed water. What is boiler feed water? You are taking water, boiling it, making steam. The steam is going into the turbine, rotating the dynamo, and we are producing electricity. The thermal electricity is produced that way. So if you use that hard water over a long time, the boiler, which is very costly container, boiler is nothing but a big container which is made of costly alloy. So that will be damaged very soon because scaling will be done. Scaling inside the boiler surface will be done automatically. Deposition of the salt will give the scaling. And as a result, what happens? The scale is not a uniform one. Sometimes, somewhere the scaling is less, thicker, somewhere it is thinner. There is a crack in the scaling. That is natural. So, the hot water and cold water imbalance will be there, producing lot of stress into the boiler. So, boiler will crack. Please, got the idea or not?
Yes.
So, boiler, inside the boiler, you have got a coating, suppose. Okay, the what coating? Some sort of salt deposition. That old, if you use bucket over a long time, there also you can find that. In the hard water, you can find the scaling. So that scale is cracked somewhere in different places. And cold water will seepage through that, means into the crack, it will enter. So, and the metal. So in the metal surface, cold and hot, both are present. So it will create lot of stress and the boiler will crack. And boiler is a very costly alloy material, so if it cracks or damages, there will be lot of loss to the company. Okay, so that's why this water before sending to the boiler unit supposed to undergo the softening process, and that's why this thing is there. It is in the industry. This type of big softening system we don't need at house. Okay, so that's why that is in the industry. So they are doing the softening, and that soft water, after softening, that hot water they are sending into boiler unit. So see, regarding water, let's understand water. Total hardness 250 to 300. These are quality of water found in the raw water. But can you tell me, you have already tested, what is the hardness level at our drinking water you have tested in the laboratory? কত পেয়েছো হার্ডনেস? পেয়েছো তো? তাহলে কত পেয়েছো বলো? এইটাই তো মনে রাখতে হবে, নাহলে আর কি হলো? কত? 69 বড্ড কম পেয়েছো, আর একটু বেশি। আচ্ছা, বর্ষার সময় হতে পারে। Rainy season you get less value, very less value. 70, 80, 69 maybe less, but 70, 80, 90 is very common. 70, 80, 90 is very common. 69 possible, it is also close to 70. Na? So 70, 80. 75.5. So her reading is also okay. So in the range 69, 75, that you are getting. So that is the hardness for us here. So that's why you don't need reverse osmosis system into our water. What water we are using, you don't need reverse osmosis because salt content is very low, very low rather. Acha. Now normally, that is a special case, but normally the hardness present in the water in the range of 250 to 300 because the water is taken from underground. Most of the cases, wherever supply water is not available, supply water is available for drinking purpose. Municipalities are giving us with some cost, not free. We are also buying water, right? So that they are taking some cost and they are supplying. But this is drinking water. They cannot supply for every purpose. Okay, that is not possible also. That's why what people are doing, taking underground water. That underground water hardness is this. pH is slightly higher than 7 I have seen. I have tested myself, around 8. That means what data written here is right. Ordinary water, if you take tap water and measure the pH, slightly it is higher than 7. Higher than 7, but may not be 8, 9 always, but higher than 7. TDS 2000 to 3000. TDS means total dissolved solid. Total dissolved solid. That is not only salt, there may be other things also, but salt is the major one. Different type of salt. But they are not always hardness causing. So this is hardness and this is TDS. The difference is there. Hardness means they are calcium magnesium ions. Majority we are considering that. And here all ions, total dissolved solid, whatever may be. NaCl is also there in the TDS. Dissolved solid, na? NaCl is considered also in the TDS, but it is not considered in the hardness. Why? Because calcium magnesium type of ion, which is bivalent, reacting with soap, not sodium potassium ion. If you have sodium chloride in the water, that will not produce hardness because it will not react with soap. And react with soap or does not react with soap, that we are considering as a hardness. Okay, that is hardness. Hardness causing ions, calcium magnesium ion. What is the another one? It's called calcium carbonate equivalence. Okay, that is very common. That other so many different salts are there, but hardness is estimated in terms of equivalence of calcium carbonate. Okay, that is called degree of hardness. The term is called degree of hardness. That is the number of equivalence of calcium carbonate per liter. And how can you make a equivalent? I just take one example. Suppose calcium chloride. 111 gram of calcium chloride is equivalent to 100 gram of calcium carbonate. Because molecular weight of calcium carbonate is 100 and molecular weight of calcium chloride is 111. Okay, so 111 gram of calcium chloride is equivalent to 100 gram of calcium carbonate. So we can make equivalence of all salts in terms of calcium carbonate. That is called degree of hardness. Why? To make one standardized. Instead of collecting information from all different things, so if you make it a single parameter, it will be easier for you to compare. And that's why calcium carbonate equivalence is taken and it is called degree of hardness of water. Achha, see, quality of our required for dyeing. রং করা কাপড়ে রং করা সো নিট ডাইং ইয়ার্ন ডাইং মানে হচ্ছে একটা হচ্ছে কাছাকাছি আছে দুটোই প্রায় প্যারামিটার হার্ডনেসটা এটা বিলো 70 and this is below 50. Actually hardness supposed to be below 50 below 70 for this type of dyeing. Why? Because dye also will react with this type of salt and that's why the color of the dye will change. You are making a particular shade na, and you will always it will be desirable to keep the particular shade. People are very much crazy about the particular shade. This color if slightly changed you will not be happy, isn't it true? Particularly for
Yes,
so that's why this particular hardness should be very low, otherwise the color will slightly get changed always. You made some color but when you are dyeing your garment, then you find the color is getting, the color of the garment is something different. What you expected is not coming like that. And everything will be rejected. The whole lot will be rejected. That happens. Na? And, so, you know, sometimes you are getting a very cheap price material from good branded material, branded clothes. You are getting at a very cheap rate. Why? Because it is rejected from the foreign country. It is rejected from the foreign country. The whole lot, as the consignment return or rejected, they are always checking the quality control, color checking, everything, and then only they are accepting. If it is not acceptable, it is just they are in the Indian that different shops, and that is happening most of the time. Sale, they are giving sale because of that. It is rejected to the outside country. That's where we are buying it at a cheaper rate.
what is the basic difference between
Slightly color change, that's why they are rejecting. Slightly changed color. Sometimes you are getting prawn at a very cheap price. Happened earlier because Japan rejected. Why? Because this pesticide level was higher than expected. Pesticide you have to use, otherwise all the prawns will be spoiled. So pesticide people are using, but there should be a control and there is a level. They are checking the level. So if it is beyond the level, they will not accept it because they are giving lot of price. So they will not compromise with the quality, never. So whenever giving in the export industry, they are knowing these things. Okay, whenever there is a little bit of defect, they are rejecting. So that risk you have to always take. Though the cost is, they are getting lot of benefits. Sometimes you can be totally spoiled also if it is rejected. Now, temporary hardness, permanent hardness, as I told in the beginning. Temporary hardness caused by this type of bicarbonates. and if you heat the bicarbonate, they can be it will be converted to carbonate, and that carbonate are insoluble. So automatically it will go out of the water, and that water will become soft water. Precipitation will take place. And you know, when you boil the water, sometimes we find lot of deposition at the bottom. देखा है कभी? When you boil the water, below the container, you find lot of white colors, the powdery like deposited at the bottom. That is actually carbonates. Because bicarbonate got converted to carbonate and it is insoluble, that's why getting precipitated. Okay, and after that you are taking the boiled water from the top, decanting. Filtering is not a good idea. Actually, decantation is better idea because all these deposits are at the bottom. If you filter with cloth, it will pass through. 50% will pass through. But better to take the decantation because these are heavier, already settled down. Achha. So now permanent hardness. These are the permanent causing of the permanent hardness. Chloride, nitrate, sulfate. These things are giving permanent hardness. And these things cannot be removed by boiling. Not so simple procedure. Temporary hardness can be removed by boiling, as well as there is another method called Clark process. That is using lime water. Lime. Ordinary lime. Calcium hydroxide. Calcium hydroxide, you may take calcium oxide, add into water, you get calcium hydroxide. That calcium hydroxide, if you use, then that reacts with this bicarbonate, producing carbonates, and you get the deposition, just like the boiling. And the benefit, you cannot boil your well. কুয়োটাকে ফোটাতে পারবে? কুয়ো পাত কুয়া ফোটাতে পারবে? তাহলে দেয়ার lime. You have to add lime. Boil, you can take one bucket full of water, you can boil. You cannot take the whole well and boil, right? Then how do you remove? You have to use lime. Lime is used for several purposes. Number one, maintaining pH. Number two, removal of hardness. If there is a temporary hardness, it can be removed. Just take slaked lime water. Lime water. Don't give huge amount of lime, but you have to use lime water. Otherwise, the well will be filled up by lime. Na? So you have to add that water, not the insoluble portion. Only the soluble portion you have to add. But the permanent hardness, what do you do? With temporary hardness, already you have discussed. Now, what about the permanent hardness? What do you do about that? We cannot use lime, we cannot boil. Here, you will have to have some procedure called Calgon process. There is a procedure called resin, ion exchange resin. These type of processes are there. Let's see. So, this is for textile manufacturing. Okay. So this is not required for you. Leave it. Temporary hardness. Temporary hardness is removed by boiling, as I told. So this is the boiling. Okay, so this is boiling. Just go through. I'm giving you time. This is bicarbonate. This is becoming carbonate, insoluble. Carbon dioxide goes out because at a higher temperature, carbon dioxide will not be soluble, so it goes out. It goes out. Here also, carbon dioxide goes out. Little bit of solubility there for magnesium hydroxide, so it will be dissolved to some extent. Slightly soluble. Magnesium carbonate is slightly soluble, but heating will cause it hydrolysis to the much less soluble magnesium hydroxide. So by the way, so these are the different methods by removal. Then permanent hardness. Permanent hardness, what we are doing? We are adding Na2CO3. So what is the change? Calcium carbonate is produced, which is insoluble, so automatically goes out, precipitated. Sodium sulfate will be there in the water, but as it is sodium salt, it will give it not hardness. It will not give hardness because sodium and potassium salts are allowed. Why? Because they are soluble. They will be soluble. They will not react with soap also, and they will not give precipitated out. When you boil, they will not be precipitated out. Sodium sulfate is soluble even at high temperature, and it will not give any precipitate. And that's why you can use in the boiler feed, you can use in washing clothes, you can take bath. So that's why hardness is removed. So that is the way hardness is removed. Okay, so now Carbon dioxide, this is the chart already I have shown you at the beginning, okay? So I skip it here.
If water contains high amounts of calcium and magnesium ions, it's considered to be hard water. Some other metal ions, such as those of aluminum, barium, iron, manganese, strontium, and zinc, also contribute to the hardness of water. These ions are found in water in the form of carbonates, bicarbonates, sulfates, and chlorides. Another way to tell if water is hard is if it doesn't form lather well. This failure to lather is due to the reaction between calcium and magnesium ions and soap molecules. The resulting molecules are insoluble in water and remain at the surface. Less soap molecules means less lather. When rain falls to earth, it percolates underground. During this process, if rainwater comes across deposits of limestone, chalk, or gypsum, which are made up largely of calcium and magnesium compounds, these metal compounds pass into the water, causing it to become hard. Hard water is generally not a health risk, but it is a nuisance. When hard water is heated, a certain amount of water evaporates, causing the minerals suspended in it to precipitate. These residues can then accumulate inside pipes, water heaters, washing machines, and dishwashers. The result is reduced water flow or blockages, stress on pipes and fixtures, spots on glasses and dishes cleaned in a dishwasher, and less effective clothes washing due to a lack of soaps. According to the World Health Organization, water containing calcium carbonate at concentrate.
I was talking about degree of hardness, milligram calcium carbonate per liter of water. That is called degree of hardness. Okay, now always it is not necessary that calcium carbonate will be there. There can be other also, but that you can convert in terms of calcium carbonate. Means one, if there is 111 gram of calcium chloride, we can consider it is equivalent to 100 gram of calcium carbonate. Because molecular it is that, so calcium carbonate molecular it is 100 and calcium chloride is 111. So 111 gram of calcium chloride is equivalent to 100 gram of calcium carbonate. Accordingly, all different salts we are considering in terms of calcium carbonate equivalent, and that is called degree of hardness of water.
Below 60 milligrams per liter is generally considered to be soft.
This is
60
soft.
to 120 milligrams per liter is moderately hard.
Moderately hard.
120 to 180 milligrams per liter is hard. And water with more than 180 milligrams per liter of calcium carbonate is very hard.
Okay, this you need to remember. Remember this overall idea, just for idea. It's not always coming in exam or something like that. 0 to 60 soft, 60 to 120 moderately hard, 120 to 180 hard, and above that very hard. Okay, so this is overall idea. So we are getting 69, means somewhere around here, right?
We are in moderate.
Moderately hard. Okay.
So drinking the hard water is also harmful for
Bad for health. Obviously bad for health.
But so there are
But
some
little bit of
minerals
some of
and
minerals is required, but it should be within this range. Within this range, should not be more than that. Little bit of salt is obviously required, but too much of salt is bad for health.
Water hardness caused by the presence of just calcium and magnesium carbonates and bicarbonates is called temporary hardness and can be removed by boiling the water and then filtering it. On the other hand, if water hardness is due to the presence of calcium and magnesium sulfates and chlorides, it's known as permanent hardness and can't be eliminated by
These are
boiling.
calcium chloride.
Removing permanent hardness requires special chemical methods, such as soda treatment, Kalgan's method, ion exchange,
Soda
or
treatment,
removal.
Calgon method, ion exchange, resin method. Okay? Normally, hardness we are calculating in terms of ppm, parts per million. That is good enough for you. Parts per million means number of parts per million part. Million means 10 to the 6. 10 to the 6. Million is 10 to the 6. So, number of parts per 10 to the 6 parts. So, number of milligram per liter. Both are coming equal. More or less coming equal. Milligram per liter is also ppm. Because milligram means 10 to the minus 3 gram and liter means 1000. So in the denominator 1000. So upor 10 to the minus 3 and niche 10 to the 3. So it is becoming 10 to the minus 6. So that's why milligram per liter is also ppm. But a bit difference in concept. Parts per million concept is used weight by weight. And milligram per liter means weight by volume. That is the difference. There is slight difference. Milligram per liter whenever you are using, that means we are considering weight by volume. Weight by volume. Weight in terms of volume. How much weight in how much volume. That we are considering. But ppm means it is always weight to weight. So in the air, how much dust particle moving. So that we are talking about ppm. There we call it ppm, not milligram per liter. That means depends on application. For liquid, for solution, we are using the term milligram per liter. But for solid gas, when some solid particle floating in the air, we are considering. So in that case, we are using the term ppm, parts per million, parts per billion, parts per trillion, ppb, ppt. Okay. 1 ppm equal to 1 milligram per liter equal to 1 ppm. Okay, only this much is good enough for you. Cannot remember all these things, so remember only this. 1 ppm equal to 1 milligram per liter. Though it is equal, milligram per liter and ppm, but then it has got a different purpose. I already explained to you. Not required. We can skip classification of water according to hardness. Yes. Okay, that already I have done. And regarding iron also, I should say that in the bathroom water, that particularly that pipelines gets damaged very soon if there is a iron contaminated water. So iron is also very bad as a hard water. Iron contamination in the water is also bad. What you find that in the pipelines, every junction there is a brown color deposition and it gets damaged very soon. Metallic pipes, particularly GI pipe. So even plastic pipe I have seen that there are iron deposition at the junction. Not only GI is getting damaged and it is getting swollen, but plastic will not get damaged that way, but deposition is still there. Iron if there, it will be deposited. Okay, at the junction it is deposited particularly. Joint, wherever there is a joint, there is a deposition of brown color. That practical experience I am telling you. Not that it is supposed to happen or not happen, not like that. I have seen this happen. So, estimation of water hardness by titration with standard soap solution, by titration with HCl. Different methods are there, but we have taken a method that you know very well, that hardness. With HCl also can be titrated, just like with phenolphthalein HCl, it can be titrated. If there is a bicarbonate, but phenolphthalein will not be good if there is a bicarbonate. That's why you can say methyl orange. Because this bicarbonate alkalinity not that high. Okay, that's why it is not NaOH, bicarbonate. That's why methyl orange or methyl red type of indicator you should use. Using hard water, consequences, precipitation of soap, deposition of dirt and all, precipitation of some dyes, scale formation. These are the different effects. And these are the reactions involved. Boiler. Boiler filled water. Boiler means container where water will boil. That is called boiler. From that we produce steam. The steam is going to turbine. It is rotating the dynamo and that's why current is produced. That is called boiler. So problem in boiler means this deposition is the problem. in the boiler. Whenever you boil this water, this hard water becomes temporary hard water, becomes soft water. But what about the deposition of the salt? That will be there. It will give scaling. That is the problem related to boiler.
Sir, এগুলো কি স্পেসিফিক হিসাবে জমতে লাগে নাকি?
হ্যাঁ, ওই তো স্কেল। It is called scale. Scale thickness কিরকম হয় দেখো। If there is a 1 millimeter thickness, then there is a percentage of heat loss, 10% heat loss. Because the heat is not, you are supplying heat from outside, okay. So that outside heat is not entering inside because scale is non-conductor. The scale is non-conductor itself. That's why if there is a 1 millimeter thickness of the scale, you are losing 10% of the heat. If you are 3 millimeter, then 17%. That way 20 millimeter thickness, 43%. So loss of heat is enormous if there is a scale formation. And this is always running, so it is not possible that so time to time we will clean it. Continuously running, you cannot stop the whole system because once you stop, lot of loss. Not only that, you cannot produce. Charging will be a huge problem. Charging of the furnace. Do you understand what I mean? That furnace means coal furnace. Okay, coal furnace. There is no switch on off. You have to take lot of coal, stacked coal, and allow it to burn. Very simple. And coal is continuously burning, and we are supplying more and more amount of coal. Coal powder actually, not lump. Coal powder is spraying. I have seen actually how it is done. Powdered coal sprayed by a blower into the furnace. মানে কয়লা তুলে ঢালা হচ্ছে না, কয়লা পাউডার ব্লো হয়ে ভেতরে ঢুকছে। Continuously there is a blow of powdered coal. Powdered coal is getting blown inside the furnace and it is getting burned because the burning is very fast in that case. If you give the powdered coal, it will be very fast burning and it is sent by blower. That is the way. So continuous process. If you stop it, then charging will create lot of pollution, lot of loss, and by that time you will have a very severe power cut for that time because there will be drop of megawatt of electricity production. That's why cleaning also not possible. So scale should not be formed and you have to be careful about that. Wastage of soap, as I told you already. C17H35 COONA. This is as an example. C17H35 COONA. Calcium sulfate reacted to produce calcium salt, which is getting precipitated out. This is soap reaction with the hard water. Reaction with dye swap.
Why the carbon chains are in so long?
Carbon chain so long. Otherwise, this surfactant property is not there. Surfactant property. It will produce bubble. It will be leathery. This property you don't get. Soapy feeling. This property you don't get. If you take acetic acid, sodium salt of acid, sodium acid is salt. You have to be long chain only. Acha, very good question. You are not listening. There is an answer, very interesting. So this soap, he was asking why we cannot take small chain like acetic acid, for example, sodium acetate. Why not? Because it has got only one polar group COOH, and there is a backside. There is only CH3. It is not a chain. So hydrophilic and hydrophobic both portions not present. If you take a long chain, at the end you have COOH. This long chain acts as a hydrophobic part and the COOH will act as a hydrophilic part. And this hydrophilic part will go inside the water hydrophilic, suppose this is water, so hydrophilic part will go inside like this. This is the hydrophilic part, COOH group, and the long chain goes out of the water. This property should be there. If not there, it cannot be a surfactant or soap. Both hydrophilic and hydrophobic character should be there. Then only it can clean the dirt. Then only it can clean the dirt. It is called micelle formation. Micelle formation is something like this. Suppose there is a dirt particle. Okay. what is this?
Yes, sir.
Yes. So that property will be there if there is a long chain. Otherwise, it will cannot clean the dirt. So that's why soap is always taken a very long chain.
So, sir, as you can say that carbon chains are hydrophobic, so they are not dissolved into the water properly.
They are going out of the water, but the hydrophilic portion is there. And what will happen whenever this is coming in contact of dirt, they are getting in good contact because this dirt is also organic, and this hydrophilic portion will surround the dirt like in this mesoly formation, and this hydrophobic part. Now hydrophilic part is going away from the dirt. It is structured like this.
Okay, sir.
Huh.
It is okay, but you can see that if you drop soap into fresh water, so it will dissolve properly. So carbon chain.
Oh, dissolve properly. Achha. Dissolve means you cannot see how it is getting dissolved. Dissolve means
As you can say
no
that
sodium salt. Na?
hydrophobic.
Sodium salt has got better solubility. Sodium salt. You are taking sodium salt, not the acid itself.
And what about the carbon chains, sir? Those are not dissolved into the water.
No, not dissolve. Hydrophilic part.
Hydrophobic, sir.
Hydrophobic part going out of the water, away from the water, getting away from the
By
water.
forming gas or something like.
No. This is a whole chain. Hey, listen. Suppose this portion is hydrophilic and this portion is hydrophobic. So it is getting attracted towards the water, so it is going inside the water. This is going out. The tail is outside the water. The tail is outside the water. It is not going out as a gas, but it is as a tail, long tail.
But sir, as we can see that the soap is totally dissolved into the water and.
No, it is not dissolved that way. It is forming floss, some sort of foam. So they are forming inside the water also. They are separate environment or moiety. So water molecules are getting repelled away from them a bit.
So at the
Not dissolution as you normally dissolve the salt or what like that. Not dissolve that way. Acha. How does the water hardness affect the textile processing? That we don't need. This I can skip. Time হয়ে গেছে জানি আর দরকার নেই বেশি এই যে these are the only name just see lime soda process base excess demineralization sequestration agent these are all removal of hardness
sir, আপনি বললেন না
lime হচ্ছে that can also react
ব্লিচিং বা চুন
no lime মানে চুন that reacts with soap producing that hard water temporary hard water hardness is removed because that also reacts with bicarbonate producing carbonate and carbonate becomes insoluble into water. They separate it out. That's why. Okay, I stop it here.